Hi, friends. Welcome to another episode of Beyond the Clouds Edge to Edge Transformation. And talking about transformation, we always need those people, call them consultants, advisors, friends, who will be direct and honest with you, who will not sugarcoat, who will not tell you things just to please you. And one of them I found is Brian Bailey. Brian, I've always admired your courage in speaking the truth as you see it. Tell us a little bit about you, your background, and what makes you who you are today.
Thanks, Shankar. Um, Electronics in general fascinated me from a very early age. I can remember back in England in kind of primary school, I picked up this magazine from the library, and it had a schematic of a transistor radio in it. And I was just fascinated by the notion that this schematic with all of these symbols could represent something which did something. And at that point, I kind of always knew I was going to be an engineer. It just seemed like such an incredibly interesting industry and kind of place to work in. So I did actually follow through on that and went to college. And the irony was then that while everything I'd been looking at was analog, I very quickly realized the math associated with analog was way more than I was prepared to deal with. So thankfully, this whole notion of digital logic was just beginning to come in at that time. And so that's what I concentrated on. And it was one of those wonderful areas where, because it was new, everybody thought it was difficult. And for some reason, I didn't. I just found it logical. And so, I got very wrapped up in the early days of processor design. And I was lucky enough that I was in England what's called a sandwich course kind of student, which meant I had a company sponsoring me. And that company was into designing computers for aircraft control systems. And so, I really did see a lot of what was going on in terms of processor design, actually using the AMD 2900 bit slice processing elements, which it was more than just picking up and using a processor. It was sort of, how is a processor working internally? And so in England, even for bachelors, you have to do a dissertation. And I proposed, based on something I'd been doing in industry, I proposed this for my dissertation. And they looked at it and said, well, this is all very interesting, but there's no way that we could afford to let you build that. So why don't you go talk to these bunch of postgraduate students that are working on this thing that I think they call a simulator? And so I went and talked to them, and a couple of members of that team are very well known in the industry, Simon Davidman and Phil Morby. And so I was the first employee of the team to actually productize that simulator. After I graduated from college, they called me back and said, come work on this simulator thing. And so that's how I very quickly went from being a designer to being in the EDA industry. And it was amazing then. It's if we think about RTL today. So Hilo was the simulator back then, and it was the first commercial RTL simulator. And my job at the time was, go off and model everything that people are designing, which meant things like, the Motorola 6800 processor or the Intel 8080 processor. And this was actually very easy in these RTL languages, but the rest of the industry was having a huge, problem with getting or adopting these concepts. So very quickly I spent time going all around the world trying to teach people what RTL was and how you programmed efficiently in it. I even at one point did a 3-month consultancy to DEC out on the East Coast to convert them, if you like, to using RTL for everything. So that really was my formative years in the industry. And ever since then, I just pushed into, other different areas of simulation. I was one of the early developers of hardware software co-verification. I did a lot of work in the early days for emulation and rapid prototyping. So I had the opportunity to push a lot of the verification technologies along. Now, you actually said, yes, I speak my mind. I then ran into a little bit of a problem with the industry when constrained random test pattern generation was being proposed, because to me, I thought it was unethical. Unethical because it was known even back then the severe limitations of the methodology. And yet everyone was, well, just think about how many more simulator licenses we're going to sell now, because we can now load all of these simulation licenses up on engineers and they can be so less efficient than they ever were in the past, but they won't worry about that because it does some good. And so I started having problems because, things like the notion of functional coverage to me, they were just fundamentally flawed. So yeah, that's when I really started, I think, getting vocal in saying, we shouldn't just be accepting things just because they do an okay job. We should always be looking for things that do a better job. And that kind of set me a little bit against the EDA industry. And so I found myself getting out of EDA and getting into journalism, writing books. I was the editor for the EDA design line on EE Times for a number of years. And then when Ed started up Semiconductor engineering, that was, just a great opportunity for me to be able to do the kind of writing that I wanted to do, and to be able to question what I thought was some of the areas that the industry wasn't really addressing or was ignoring.
That's wonderful. And that's exactly why I read pretty much everything I get my hands around when it comes from you or from Ed Sperling or from semiconductor engineering. The intellectual honesty is amazing. And it doesn't mean you're always right, but at least you're not obviously lying or exaggerating. And that's really valuable. In fact, I would call everything else is more like scientific astrology or marketing or sugarcoating. Um, Given the scenario we are in, Brian, there's so much going on. Predictions about how AI is going to change the world. Even AI is going to rule the world. What do you think is really happening, both in the overall field of artificial intelligence with generative AI, and specifically in the area of verification and design? What can AI, in your opinion, in your educated opinion, really do for us today?
I think that there's a bigger issue here, Shankar, which is we've kind of got a notion of Moore's law ending in the fact that we can't just cram more and more functionality onto a chip and expect it to do what we've done in the past. And I think that is creating a fundamental rift in our industry, in the fact that we have to question many decisions that were made in the past. To give you an example, and I think this was very well put, at the DAC the Cedar Luncheon, which is held every year, and I've just written an article about that. It was said that there are many, let's say, architectures for processors that were proposed in academia that were far superior to what we had in the industry, but they were ignored because computation based on a von Neumann architecture with Moore's law giving us the cadences that we were seeing every 18 months was good enough. We didn't, as an industry, have to take the risks because there was an easier alternative. And so Moore's law made us fat, dumb, and happy, if you like, in the fact that it was easy not to take risk. Well, with Moore's law coming to an end, we have to go back and look at some of those again. And AI does play in here because AI is not a control-driven algorithm process, it's data-driven. And so we're beginning to see people now start questioning what's the future of von Neumann? Sure, there's always going to be some control operation, but that's really a minor operation compared to the kind of compute that we need for AI, the kind of compute we need for graphic processing, the kind of compute we need for security. And, all of these things are data-driven processing operations, and this requires a fundamentally different compute architecture. NVIDIA foresaw some of this, I think, quite some time ago, and as an industry, we have to be quite thankful to them in the fact that they said, okay, we've got this GPU, but we want it to be a general purpose programming platform. How do we bring the programming community along? How do we retrain them? How do we get them to think about data flows and parallelism, concurrency? And so the development of something like CUDA was an incredibly important development, I think, with the industry. Now, when we go to AI, that takes things a little further. We know that AI requires massive amounts of the multiply, accumulate function, and we kind of organize them in a way that allows an AI algorithm to operate. But we need to go further than that. We need to think about what does a generic processor look like that can do AI, that can do video, that can do any number of functions based on a data flow architecture, and where are we going to get the languages, the domains of computation, if you like, that go along with them. So there's a whole bunch of changes that are related, not just to AI as to how we use it, but AI as it's going to drive our computing platforms and the architectures in the industry.
Brian, I truly admire, again, the details and the honesty with which you're speaking this, that Moore's law, as it stands today, really applies to von Neumann architectures. It's not just the geometry, but the kind of architectures we have. So clearly there's a need to diverge from these architectures, which may not serve us going forward when we start using AI and basically machine learning and other algorithms. Jim Keller has made a very interesting statement recently. He's currently the CEO of Tenstorrent. He said, if aliens were to come on Earth, say 50 years from now, they're not going to say, oh my God, we found CUDA. It's going to be different. So where
Yep.
do you think? So CUDA definitely was a big step forward in terms of proposing ways of doing things. And it served us really well in the GPU era.
Mm-hmm.
What kind of architectures do you envision will come into place to make real AI a possible, as well as useful, amenable, and so on?
Right. So we within AI at the moment, we do have a few things like, Google has been developing an awful lot of stuff. There are other frameworks that have been developed. One of the big stumbling blocks, if you like, at the moment is when a Tenstorrent or anybody else develops a piece of hardware, you've got this massive compiler problem in between. And that is, the area I think that there's going to be huge innovation, because it's going from how do you define the problem to how do you get that to run on an arbitrary piece of hardware. In the von Neumann era, if you like, yeah, it was the compiler, and it was trying to extract some parallelism from the input. It was trying to work out how to map it onto a particular instruction set architecture. But the problem we're facing now with these data flow architectures and AI, it's a much bigger problem because of all of the concurrency. And it's not just enough to map it in perhaps, how does it get an operation done the fastest? We've got to consider the silicon as well, and power, and how we distribute heat, and how we get that heat out. And there are so many factors that are going to come into play that in effect the compiler has to understand all of these concepts in order to get the maximum out of the silicon. Hardware engineers can work out, how many tops per watt they can get into their hardware, but without considering the data flow that goes through that, and the scheduling, and so many other things, it's sort of what is the real workload that you can get through that architecture, basically without it melting. And so, the compiler's going to have to be thinking about those kind of issues, and it's never had to think about concurrency, thermal, and so many other issues in the past that now are going to become important compiler operations.
So what you're kind of suggesting is software that's hardware intelligent, understand the characteristics of the underlying architecture, and therefore route its algorithms in such a way that it doesn't burn up the hardware. Is that what you're saying?
Very much so. Software and hardware, I've been dreaming about them coming together for over 20, 25 years now. With Seamless, the hardware software co-verification product I worked on, I did a lot of work in, what was called ESL, electronic system level, which is where software was actually going to start influencing hardware. We're only just beginning to see even the small signs of that now with RISC-V, of being able to analyze the software and tune a processor to execute that more efficiently. But I don't think we've really even reached that point yet where software and hardware, the teams most of the time still don't talk to each other. We're still not doing co-design or co-development. And yeah, we've got to get to the point of all of this domain-specific design. It's software driven. We're no longer just creating hardware to run software. We're getting into an era where it's software that needs to execute, and the hardware's got to just do that as efficiently as possible. And so the workloads are becoming so important, defining them. And it's putting a whole new kind of notion on what it means to do verification. The verification test patterns, they're synthetic workloads that don't represent what it is that we're trying to do. And so scenario-driven design, which is based on software, I think is going to be something that we're going to see more and more of in the future. Not only does it ensure that we get the functionality right, it means we don't have to be margining as much as we did in the past, because we don't care if hardware can work at the extremes. We care if it can perform well enough on the computation task that's been given it. And that changes a lot of the design optimization sort of mentality.
A lot of the optimization we've done so far has stopped at the chip or maybe the chiplet or the SoC level. But then when you get to these large data centers or the cloud itself, we just slap it together, right? In other words, we optimize and micro optimize every TOPS we can get or every CPU cycle we can get at the chip level. But then when you put all these chips together to create a huge server or a huge cloud, do we really do that kind of understanding, or do we need to do that? What's your opinion on that?
I'll be honest and say I don't understand enough about how they put cloud and data centers together. So I'm not sure I can really provide too much insight there. The one thing I will say is I think they've done an awful lot of development in system redundancy that we could learn a lot from. It's a very rare event when a cloud goes down. The cloud hits an error, it heals itself. It immediately isolates the part of the hardware that went wrong, or it routes data to and computation to other parts of the cloud. I think if we want to start thinking about reliable electronics for things like, the automotive industry, I think perhaps there's an awful lot we can learn from what the cloud has done to make reliable computing something that is attainable. So yes, we could look at it as, is the cloud being developed in the best possible way? I don't know about that, but what I do know is there's a lot we can learn about what they have found when doing that and apply it in other domains.
And speaking of large systems, speaking of the cloud, we keep hearing the word digital twins and fully autonomous systems. What's your opinion on that? Is it just a linear extension of the idea of design and emulation and hardware software, or is there much more to it?
I think there's quite a bit more to it. It's yes, our industry, the semiconductor industry, has always had a digital twin. But it's been a digital twin in a very restricted manner, in the fact that there really aren't multiple levels of abstraction. There definitely aren't multiple domains of physics that are involved. We have started, even within the semiconductor industry, to have problems with the digital twins that we created when we're looking at something like thermal, because the timing of the design is working on the nanoseconds and picosecond kind of time frame. Thermal is working on the seconds, even to minutes of time frame. And so bringing such diverse time frames together creates problems if you don't start bringing in abstractions. But of course, as soon as you bring in abstractions, you have to understand the limitations of those abstractions. Otherwise, you're going to start getting false information being provided. And that, I think, is something that within the semiconductor industry, we haven't fully learned. When you start looking at digital twins in the broader sense, you're bringing in not only the semiconductor component, you're bringing in mechanical, you're bringing in fluidics, you're bringing in every aspect of the complete product that you're trying to put together. And so I think it's a lot more important to start thinking about, what can a model tell you, how quickly it can tell you, because if it can't tell you quickly enough, then the information's not useful. So there's many more aspects, I think, with the digital twin that are being considered way beyond what we have in semiconductor.
In fact, yesterday I was talking to David Fritz and I asked him about that, about how soon do you think level 5 autonomous vehicles will be there? And that's a hard question to answer, isn't it? How
I
far?
think it is, and I don't even want to predict if and when it will ever happen or how it will happen. Um, there's always, and I know always is a strong term, but there's always going to be non-autonomous vehicles that are on our roads. And so they're always going to have to deal with the completely unexpected. The driver who chooses not to obey laws or to do things that are rational. I think there's always going to be problems with autonomous vehicles if we allow them to be completely intermixed with real life. If we were to think in terms of, okay, there's going to be one road for autonomous vehicles and a different road for maniac drivers, then yes, maybe it becomes possible. Maybe if we rethink aspects of, yeah, signs are not dumb, signs become active, or roads become active, then I think a lot more becomes possible because it can become more rational. But are we really going to spend that much money on the infrastructure ahead of time to make it happen? I don't think so. So, yeah, autonomous driving will come at some point. Will I ever use it or trust it? I don't know. The interesting thing in some respects with it is, they say that autonomous driving is already at the point whereby it's safer than a human driver. So we do have to accept that autonomous driving will never be 100% accurate because humans are not 100% accurate. The problem is when something does go wrong, we don't like it when machines make an error. We expect machines to be perfect. So yes, it becomes a very interesting verification problem, if you like, of we have to now deal with what does coverage mean for autonomous driving, and is 100% coverage good enough? I sure hope we are not using coverage as defined by constrained random test pattern generation as our indication as to whether autonomous cars are safe or not. We need more effective ways of defining what coverage, what completion, what many of these attributes of safety look like, and we don't have that today.
It reminds me as a parent, often we have unrealistic expectations from our children, much higher than what we have from ourselves. And are we doing the same thing when it comes to expecting unrealistically that machines will do a far better job of getting things done than humans? In other words, they'll hallucinate less than humans hallucinate.
Well, I don't know. I mean, say if AI does really become cognitive, it's maybe it can hallucinate as well. Um, um, I think it is a problem of rationality. We've got to have the confidence in it. And how do we measure confidence in something, like AI? As many of the people even working on AI say, well, we don't really understand how it works. We just observe that it does. That to me is a scary position to say, and we're going to trust it with our lives. I'm not satisfied that we know how trustworthy they are at the moment. And so when somebody says to me, they're safer than humans, I say, how did you measure that? Because I don't trust their measurement metric at the moment, because there's just insufficient data for me to get a good judge of whether they're lying or not.
Yeah, yeah. We've already seen the limitations of constrained random verification, as you said, or just throwing more data or more cycles is not enough.
Mm-mm.
The quality matters far more than the quantity. And the question is, how do we qualify it's of a high quality? What's our metric? Very
Right,
true. Very
right.
true.
There is no metric today, and without a metric, and it doesn't even have to be a physical metric per se, but there's got to be something which gives us the confidence to
Yeah.
say, I am willing to trust something. Do you trust your computer? Yeah, we've got enough years of experience that we say, yes, we trust it, even though we know in the past it's made errors. We know that every now and then not quite so much these days, but the blue screen of death is still possible. But we trust it most of the time because we have enough evidence that it's done a good enough job. Um, I think it's interesting when people talk about phones. And in the early days with phones, there used to be those things, oh, my phone just crashed. Um, we kind of accepted it, even though we didn't know why it was crashing. We didn't know whether it was a software bug. We didn't know if the hardware was unreliable. Um, but we didn't really care if we had to reboot it once a week or once a month. That was acceptable for what we expected for it. Um, I don't expect to have to reboot my car once a week or once a month. I don't expect to get a blue screen of death from it. I don't expect it to crash. I don't expect it to, you know, we don't have the experience for these expectations yet to feel comfortable that it's something that we can rely on. I look at some of the crash reports of the autonomous cars, and it just amazes me some of the people that are willing to trust so easily, so readily, that these cars can drive themselves and they can take a nap or they can work on their computer or what have you. I don't know where they get this unfounded trust from, because I don't think it's there today.
It reminds me of the Dunning-Kruger syndrome or the Dunning-Kruger effect. The less you know, the more you think you know. And
Yeah, but it's kind of a little different when you're trusting your life to it.
that's true. That's true. But we've had pacemakers, we've had all these kinds of instruments that we use, even in for heart or for many disease conditions, and they seem to work fairly well within the FDA constraints or
Right, but that
regulatory.
is a little different, Shankar. If
Yeah.
you're talking about a pacemaker, the the expectation is I should have died already.
Mm,
Now, this device is going to attempt to stop me dying. So anything it does is better than what it would have been without it, which is dead. You're operating in the completely opposite domain here. You don't expect a car to kill you. If you did, you wouldn't get in it. Um, but yes, we know that there's a risk every time we do get in a car, but there are certain levels of risk that, you're making these risk assessments all the time. Do I overtake that car in front of me? Is it
that's
worth
true.
it?
That's true.
I'm not sure I'm willing to let the car make those decisions for me yet.
For a perfectly normal, healthy person to give the key to their life to a machine is scary,
Right.
especially when there are not enough metrics to judge whether the decision taken by the machine is in some form or fashion better in a consistent way than my own judgment. That's
Mhm.
true.
So let's just go back to the pacemaker, because there are two sides to that. So as we said, if the likelihood is without it you will die, then putting it in is likely to be better than nothing. Now, if the doctors started saying, okay, everyone's going to get fitted with a pacemaker because there's a chance that at some point in the future you might die and this might save your life. Oh, but by the way, there's a very slight chance that the pacemaker will fail and it will kill you when you didn't before. Now, that is a very different equation. And so it's based on the circumstance by which you're saying, is it, providing, is the benefit better than the risk? And if you don't need it, but you're going to put it in, then the risk is a lot higher than the benefit. So even with the same device, it can be both ends of that equation.
Very true, very true. And I agree. That's why solving a problem like making reliable autonomous vehicles is hard. How about problems of inferencing, such as medical diagnosis, uh, measuring the toxicity of the food we ingest in ourselves, or better agriculture? Do you think we are ready yet with the kind of systems we have to create things that are better than what we humans can do? Or do it faster?
I think it still comes down to how do you get the level of trust that's necessary. So I think we're going to see a lot of humans assisted by AI in medical or in a lot of other fields before we completely trust the AI. So, I think it's great that AI can scan, let's say, millions and millions of mammography scans or other medical charts and identify potential things, and then to have a human verify them and say that's good, that's bad. And sometimes they're going to say, wow, I didn't see that, but AI did. And I think we're beginning to see that in a few cases. But we've also got to make sure we don't go in the other direction of AI saying that, you have a tumor when you don't. And there are just as many cases where a human can say, no, the AI is wrong. But you put those two together, of the AI identifying things that the human missed and the human being able to filter out the things that the AI gets wrong. And I think you've now got a winning situation. So it's a human empowered with AI, I think is going to be very, very beneficial. Do we need to get to the point of saying, yeah, but when will AI just be able to do it on its own? Why do we care? Why is that a goal? If the
I agree.
combination of the two is the best way to do things, then let's just leave it at that.
It's like the hardware software co-simulation or hardware software design. We can have an AI human design, which includes, not excludes one against the
There's
other.
no reason why we shouldn't enhance human intelligence with artificial intelligence. I don't
Yeah,
think in many cases the right thing to do is to replace it.
yeah.
It's to meld them together to create better solutions than either could do alone.
And we have been doing that all along, haven't we? With calculators, with computers, everybody relies on a software, piece of software to do our taxes, everything. So we are already augmenting intelligence using machines for a long time. And it may just get a little better, right?
Right. I mean, one of the big questions in it, is can AI ever truly be creative? And that's something I've been thinking about recently. A lot of my friends have been arguing a lot about, oh, it's wrong with these kind of generative art things of, they look at everybody's art and then somebody says, give me a picture of this in the style of Monet or what have you. And it generates a picture and somebody puts it up and says, this is my art. And, so that's got me thinking a lot about, well, that is how humans create as well. It's if we look at a lot of things that other people have done in the past, we look at a lot of techniques that artists have used, and then an artist will say, I like the way he paints. Now, let me go do this landscape or this portrait or what have you using that kind of technique, and that is their art. So in that respect, these art programs are doing creation in the same way as humans would. Can they actually come up with something absolutely, completely new? Maybe not, but it's very rare for humans to do that as well. Maybe that actually takes a bug in the AI, and then suddenly it has created something accidentally, but maybe that's the way humans do it too.
Yes, yes. And, new science is rarely a science. It's actually an art.
Mm-hmm.
Somebody disbelieving Newton's laws came up with
Right. So
relativity.
maybe it's that bug in the cloud, that one processor that went haywire for a little bit, gave you the wrong result, and it didn't get caught. And suddenly it actually creates something that's never been seen before. And somebody says, my God, it's just created something completely new.
Yeah.
So, maybe because I wouldn't mind betting that's the way creativity happens in the brain as well. It's normally a short circuit, a momentary short circuit, or a moment of madness, or what have you, that is creativity. So maybe we shouldn't actually try and make hardware perfect.
In fact, I was asking that question to Rob Aiken. I asked him whether hallucination, as we see it in generative AI algorithms, was a bug or a feature. And he said that it could be the beginning of attempts to be more creative.
Right. Yeah. I mean, and it doesn't really matter if it's designed to be that way, or whether it truly is just an alpha particle hit that memory and changed that bit, and that created something completely new. So maybe we should allow for hardware to be buggy, as long as there is something that can then weed out the things that get generated that are dangerous or bad.
Harmful. Yeah, yeah. We can have some kind of checks and balance,
Right.
a formal verifier or an assertion checker to
Mm-hmm.
at least weed out things that can hurt us.
Right, which
Speaking of,
is one of the problems with AI today, that
yeah,
when it does get out of, let's say, its domain of comfort and
mhm,
starts experiencing things it hasn't seen, when we get all of these, the universities that show here's a stop sign, now here's a stop sign with a change in it that you can't even visually perceive, and yet the AI no longer says it's a stop sign, it's a zebra or something. It's a humans would never make that kind of mistake. Even a child, when it sees something that it's never seen before, it can describe what it sees as, well, it looks like a horse with a very long neck. When it first sees a giraffe or what have you. AI's got to get to that level where we can actually expect a rational response from it when it sees something it's never seen before. And at the moment, it can't do that. It just goes off in the weeds and gives wrong answers. So we need to get a rationality kind of aspect into AI.
a lot of people are talking about how AI could be, an assistant in the education process. And in fact, the fundamentals of what to educate or what to learn seem to be changing in the era of intelligent machines. What's your opinion on that? Do you see us going through the K through 12 education and college degrees and all that? Or is that completely outdated, given that a lot of the information out there can be summarized fairly quickly using machines today?
Should we be teaching children how to use a slide rule? Should we be teaching them how to use a calculator? I think we should use every tool that is available to help people learn. And that's going to change through time, and change is difficult. There's a lot of people that are using AI to cheat on exams at the moment. Well, yeah, so exams have got to change in a way that it's not an issue anymore. They can use the technology there to help them. I can remember going through college, the exams that I feared the most were the open book exams, where you have access to all of the material that you had been taught, because you knew that that really wasn't going to be the key to how well you did in that exam. So I don't see any reason why AI shouldn't be inserted into education at all levels if it's useful. And yes, the education system has to change, knowing that it's there. And so, yeah, maybe education has to be, yeah, you can use generative AI and now critique it. So now you've got to think about what it created, how it created it, why it created it, and then rationally think about it and say, could I have done better than it? Or things like that. So you use it in different ways.
Clearly, education is going to change the way we practice medicine, the way we practice practically everything as a profession is going to change. And with that, there will be job losses. There'll be job losses in areas where a machine could fairly easily replicate or do things that human beings are doing today. What do you think is likely to happen, say, 5 years from now, in terms of will there be less jobs, more jobs, different jobs? What do you foresee coming to us?
I was absolutely distraught at the number of horses that lost their job at the beginning of the Industrial Revolution. It was the worst thing that could have happened for horse employment that you could ever imagine. And we still haven't got over that. I think
And what about the cowboys?
I think it's looking at the problem completely wrong. I don't think AI is going to take away jobs. I think it's going to create new opportunities. And just like every technological advancement that's ever happened since the Industrial Revolution, it takes jobs away from some people, it creates jobs for other people. There's always going to be a problem in the transition, because there's going to be people who cannot be retrained to do what is now necessary. And when I think about growing up in England under the reign of Margaret Thatcher, that was a human displacement of people when Margaret Thatcher decided that England was no longer going to be a manufacturing country, that it was too inefficient, that it had to concentrate on the areas that it could win and be a world leader. And basically, she fired half of the country, quite literally, by the busting of the unions and shutting down most of the coal mines. She shut down shipbuilding. She shut down the steel industry. She shut down half of the jobs in the country. And so it was a matter of how do you start retraining everybody to be what we as a country now want to be, which was, in technology, in AI, in the intellectual kind of capital industry. And it took many years. England went through massive unemployment. But if we look back now, it's if we look back now just after Brexit, then maybe we have a different opinion than it was just before. But there was displacement, but there was fundamental re-architecting that went on in the fabric of the workforce of that country. And AI is going to create a disruption, sure. And in the short term, there will be jobs lost. But there's going to be so many more jobs that will be enabled by it that 10 years' time, you'll look back and say, who lost their job? Was it the people in the call centers? Was it people here? Nobody's going to care.
Brian, you've worked in many different roles from the early days of high-low. I think that was Cirrus computers, right?
Mm-hmm.
That productized high-low.
Right.
Then
well,
came
it started off in Brunel University. Okay. Cirrus bought the commercialization rights from the university to it. So they kind of took it public, if you like, and productized it and started selling it. Now, yes, Cirrus, they had several parts to the company. One part of it was test. Now, by test, we mean they were doing test pattern generation by sticking pins in a schematic and running colored string between those to work out how you activated a path from the inputs to the outputs. And they saw simulation technology, and Hilo had an automatic test pattern generator built into it. So they saw it as both a way to modernize their industry, and at the time, this was one of the failed aspects of AI that went on 45 years ago. That there was the notion of you could have knowledge-based systems. And so in England, their version of AT&T, so British Telecom, put out a contract to automatically have a system that could automatically generate tests. And so Cirrus saw Hilo as being a way to get that contract and to build the next generation of system on that technology, which use these knowledge-based systems, i.e. learning systems, that could look at what worked before and how can I project that to what's going to work in the future. We didn't have much of the AI technology we have today, but it was an early attempt at it. Obviously, it failed. But test was a very important area back in those days. Another thing Hilo had in was a fault simulator. And that was for the test industry. It's sort of, how do you take a design, how do you inject faults in it and find out if those faults are going to be detected? And we generated very sophisticated algorithms for how we would not inject faults serially, but how we would generate or inject hundreds of faults into a circuit at a design and work out which ones of them were and weren't detected. So yeah, things have moved on a lot since then, but it's kind of interesting that that was a very early attempt at artificial intelligence.
Seeing all this technology, do you think we'll be more connected or less connected with nature? Because it's so easy for kids today to get engrossed in video games and stuff like that. And yet there's that feeling of emptiness. I mean, I spent 4 hours today in front of the computer, and it gets on my nerves sometimes, Where do you think humanity is going to go with all this reliance on machines? And is that good for us overall?
I don't think it is. And for me, that's why right now I'm kind of sliding into retirement so I can spend more and more time outdoors, connecting with nature, doing things in my garden. That to me is becoming a more and more important part of my life, because that's where you get real enjoyment, I think, not from sitting in front of a screen talking to each other. one of the blogs I just wrote was kind of looking at the at conferences and kind of questioning, are in-person conferences the right thing to be doing? And it's kind of interesting that almost every feedback comment I've got says, yeah, we really need to connect with people. It's the most important part of conferences. And while I agree that it's really nice to connect with people, we're denying ourselves those other connection possibilities all the time. It's almost as though conferences are the excuse now to connect with people. But I was making an argument that goes way deeper than should conferences just be the place where people can physically connect. I think there are ethical questions about it. The amount of carbon that gets burnt to go to conferences, the question about whether, is it fair to people in far-flung countries that can't afford to get to conferences that their work potentially doesn't get seen? Because like for something like DAC, you have to guarantee that if your paper is accepted, you will be there. Well, what if you don't have the means to be there? Well, now you're not a candidate to be in the conference. And long term, is that ethical? If we really want to get the best technology, then we have to make it fair and open to everyone. And today it's not. It's stacked in favor of rich countries, rich universities, and we have to find ways to change some of that. So conferences, yeah, there may be a great place to get together, but that's only one of the aspects that we should be considering when we think of the long-term projection of some of these things.
Brian, you bring up a very, very interesting topic close to my heart. I grew up in the impoverished neighborhoods of Bombay and had much less access. And once I went to the IIT, suddenly the access expanded.
Right.
But I always ask myself the question when I spent 5-6 years in rural India, will technology make it easier for people to access each other, to create opportunities that didn't exist before? And therefore, will technology democratize and make it more accessible for people to find opportunities that weren't there before? What's your opinion on what's happening today?
Technology can have a fundamental impact if it is fairly applied. So I can actually give you one very interesting example with where I live now. It's if I live somewhere where that background view that you have is what I've got right outside my window. I live on the coast in Oregon, and I look out over the ocean on a place called the Three Arch Rocks, which is the first wildlife protected area west of the Mississippi.
Wow.
Well, while that's great, we don't have cell phone coverage.
Ah.
That creates a very interesting problem. I deal a lot with high technology, and it's getting to the point where there's an expectation now that everybody has cell phone coverage. You wouldn't believe the difficulty that actually creates for me. The number of times an organization will say, "Oh, we need to check your identity. We need to send you a code via text." Sorry, no can do. Where my phone is and where my computer is, they cannot be brought together to do a multi-factor authentication in that manner. And a lot of companies don't think about this. They don't provide an alternative to how does somebody without a cell phone or without coverage deal with this. So while technology can be a democratizer, it can also be a separator in those who have and those who have not. So we've got to be very careful how we apply technology to make sure that it really is open and fair to everyone. And we're not creating additional bias in the system between, in this case, it's sort of urban and rural. So we've got to be very careful about some of the decisions we're making.
You have worked in many different areas. Although it's been more or less design verification, you worked at various levels of abstraction, from analog, IP, SoC, systems, and now as a journalist. Which part of your career have you enjoyed the most and why?
The part of my career I enjoy the most is when I'm looking at or trying to answer the question, what could be? Where you take away the constraints of business and you think about what an ideal solution to a problem might be. And then you work back and say, is there a way that that could become a reality? So I think the time I spent working in ESL was perhaps the most enjoyable, because that really was saying, let's project forward to what systems are going to be like in the future, and let's see if we can devise design methodologies that would fit what those needs are going to be. It was completely diffused when the IP era started, because the IP era changed the whole equation that in making reuse a lot more effective. So you no longer had to do as much system design as it was expected that we would need to do if IP hadn't have come along. So that, I think, is the most interesting part, when you can free yourself, even if for a while, to think what lies beyond just the linear projection of where we are today, to look at a point in the future and to look at what ways could you get there, and then to put on the overlay of now what might be possible.
You get me into the science fiction domain. So instead of this universe, you simulate or get into multiple universes
I think
or
in some
metaverses.
respects it is very similar. It's if you start creating pictures that may be not realistic, but you can sometimes get an awful lot of insights from them. Just like, it's amazing how much science fiction actually got right.
Yeah.
And sometimes it's by putting out that abstract idea, that notion, that it becomes something that people can strive for. So I'm not sure that it's science fiction projected forward. It's if they put something out there as a goal, which people were then led towards. And so I think that's what we do in technology a lot. It's things are put out there, and sometimes people will follow.
It's like I see a resemblance between good science fiction and benevolent politicians.
I think benevolent politician is an oxymoron, but
Good science fiction is real. Yeah. Well, with that thought, I think we should bring this discussion to a conclusion. There's so much more I keep learning from you, Brian. I may not have explicitly acknowledged that, but I really like the way you write, and the journalism that you do is so immensely interesting and useful. In my last full-time job at Intel, I used that a lot to talk about where the next level of verification challenges, chiplets, and all that would be. So thanks a lot. And to people out there, yes, I'm looking for people who are divergent in their thinking, not necessarily following the structure that's been given to us and just extending that, to be able to take a stand, to be able to look at things differently with a lot of courage, not afraid of being wrong or getting it wrong, but to look at all the possibilities. So please come forward, talk. And thanks again, Brian, and thank you for being you.
Thank you for giving me the opportunity, and thanks for putting up with my ramblings.